Problem set and oscillations that I have to do. I'm going to really do this quickly because the problems were already worked out in class. Number one, first find the K. And you don't need the amplitude for the B part. And you find the frequency. Straightforward question. And you have number two. Find the frequency using the spring formula, because this floating object really behaves like a spring compressed. So find K and then use that K to find the frequency. Number three, first X is given. You compare it with the general equation there, and you can immediately see that omega is in place of 5 pi by 4. So omega is in place of 5 pi by 4. So omega is 5 pi by 4. And frequency is omega by 2 pi. So that gives you 5 by 8. And time period is the reciprocal of frequency. And velocity is the differential of displacement with time. So you take the differential. Remember that cos is negative sign. You got to write that omega one more time. That's why you find this term. And then to find the displacement at 0, just plug in t is equal to 0. That equation. Do the same to find the velocity at time 0. So plug in t is equal to 0 in this equation, that gives you that. And again, to find the acceleration, differentiate that again one more time with time. And then finally plug in t is 2 seconds to find the velocity at 2 seconds. Number 4, find K first. Get is 73.84, and then time to move from maximum to equilibrium is t by 4. Yes, because it's quarter of an oscillation from equilibrium to the maximum is a quarter. So find the time period. After you get the time period, divide it by 4, because that's the time it needs. In the fifth one, find K again. And then remember that the elastic potential energy of the spring gets converted into kinetic energy of the ball or the bullet, whatever it may be, and then make velocity the subject. That's it. We've got K and the mass of the ball times the maximum compression, and you get the velocity. Number 6, it's quite important to remember that omega is square root of K by M, and also omega is 2 by F. So you can put them both together. In fact, that's how you get the formula for frequency, and then make K the subject. In the B part, total energy is 1/2 Ka squared, which is the maximum of potential or the maximum of kinetic. Same formula. And since you know K and you have the amplitude, plug them in and get the answer. In number 7, this clock makes, any pendulum clock makes one oscillation in 2 seconds. So the time period is 2 seconds. Number of seconds in a day, 86,400. And it takes 2 seconds for one oscillation. Therefore, number of oscillations in a day, half of that. This thing loses 26 seconds in a day, which is 13 oscillations lost. So the remaining number of oscillations is 43,187. Okay, which is this, take away 13. And then, because we know that the time period depends on the number of oscillations, you just take the ratio. So you get the new time period in terms of the old. And then the formula for time period is here. The 2 pi and the g get cancelled, rearranged to get the new time period in terms of the old. And of course the old time period could have been found out using this formula where you know gt is 2, so you could get that. Therefore that's why you find that number here, and then you get 0.9924 meter. In number 8, the amplitude in damped motion changes according to this relation, and you know that gamma is b by 2m, so rearrange the a by a naught is e raised to negative, but do notice that when you make this positive, this left side is flipped. Instead of a by a naught, it's a naught by a naught. And then we're looking for b, so take the natural log on the left side, rearrange to get b as the subject, substitute and calculate. Now b is called the damping constant or the linear damping coefficient. In this case, the shaking will be maximum when there is resonance. That means the frequencies are equal. The frequency of rotation of the tire is given by omega, is v by the radius, and the frequency of the spring, so omega, is square root k by the mass. So put them together, make velocity the subject, and calculate. Also remember that since the 4 tires are supporting the total mass, each tire supports only a quarter of the mass of the car. So get the answer. Number 10, it's a physical pendulum as shown here, and as a formula, moment of inertia in this case is ml squared by 3 because it's a rod rotating about an axis passing through one end. It's ml squared by 3. So h is L by 2 because the center of mass will be exactly halfway through. And then plug the numbers in, get 1.64, and if it was a simple pendulum, this time period, you can find the length just by simply making length the subject and calculating. The velocity in simple harmonic motion is given by this formula. Since the velocity is given to be half of the maximum, you take this as 1 and this is half. Square both sides, rearrange. You get the displacement in terms of the amplitude. The pebble surely loses contact with the highest point if the board moves at an acceleration faster than g. Now, acceleration is given by omega squared x. But omega is 2 pi f, so square that. And you put that equal to g and find the amplitude is 4 times 10 to the negative 2. Thank you.